Hi everyone, thanks for tuning in to our next video. Title, Simplify Radical Expressions. So you see some square roots here. The word radical actually means a root, square root in the case of what we're doing today. So we're simplifying expressions that involve square roots. And you might say, well, that's easy enough. Well, yeah, maybe if it's a perfect square. Like if I gave you, let me grab a sheet of paper here. Like if I said to you guys, okay, what's the square root of 25? I mean, you've known that for years. That's 5 because 5 times 5 is 25. Or if I said, what's the square root of 16? You would say, oh, that's 4. That's easy. These are perfect squares. Or if I said, what's the square root of 9? Well, that's 3. We're not dealing with these easy ones today, okay? We're dealing with taking square roots and simplifying non-perfect squares, like this first one, square root of 8. But it's actually pretty easy to do, actually, if you just follow my little recipe for success here. So, what you got to do when you're finding the square root of 8, well, the first thing not to do, at least on this lesson, is I don't want you using the calculator. Like oh, my batteries are low. I don't want you typing in square root 8, enter, and telling me that the answer is 2.828427125. It's true, that is the decimal version, but I don't want that today. I just want to simplify this without a calculator. So this is what you do. You have to, now this is going to seem fancy, but it's not. I'll write it. You have to write this guy, 8, as a product, which means multiply, of its prime factors. Okay? So that just means numbers that get multiplied together to make 8. But each of those numbers that you're multiplying has to be prime. Okay? So prime means, it's the number is only divisible by itself and 1. So like you can't go any further on a prime number, which I'll show you here. So let's look at 8. So let's start writing 8 as a product of its prime factors. Well, the easiest way to get there is just to start thinking about two numbers that multiply to give us 8. So that's pretty easy. Maybe we say 4 and 2. Okay, 4 times 2. Now, the 2 is prime. Because how do you break a 2 down any further? It would just be 2 times 1. So once you get down to a number that you could only break down again to the number and 1, you're done. Now 4 will go a little bit further. 4 can be written as 2 times 2. But now these are prime because they can't go any further. So I'll circle that and I'll circle that. So the number 8, written as a product of its prime factors, would look like this. Square root, I'm replacing the 8 with 2 times 2 times 2. These 3 circles. And I mean, you can check it. 2 times 2 is 4, and 4 times 2 is 8. There you have it. So now what do? Well, you find pairs. You want to find a pair of similar numbers. So we've got a pair of 2s, so I'm going to circle those. That's going to make like a perfect square. 2 times 2 is 4, right? Now think about this. What's the square root of 4? Well, 2. So we bring the 2 to the outside, and then you're left with this 2 on the inside. So the simplified version of the square root of 8 is 2 square root 2. So let me show you. So here was the square root of 8. Now watch what happens. 2 square root 2. Watch how it makes the same decimal. Ta-da! So you can write it like this, or you can write it like this simplified. Okay, let's try another one. The square root of 24. Okay. Well, the square root of 24 is nasty if you do it on a calculator. Watch. The square root 24. Yuck. Let's see if we can simplify it without a calculator. So we start in what times what makes 24. Now, we have options. We could do 12 times 2. We could do 6 times 4. We could do 8 times 3. No matter what you pick, everybody, you'll end up at the same place, because no matter which direction you choose to start in, eventually it will break down to the exact same prime factors. So I don't know, why don't we try 4 and 6? We'll go right in the middle, 4 and 6. Now neither of those is prime. We can go further on a 4. 4 can be written as the product of 2 times 2. And 6 can be written as the product of 2 times 3. I believe these 4 numbers here are all prime. So 2 and 2 and 2 and 3. Can't go any further. So I'm going to write the square root of 24 as the product of 2 times 2 times 2 times 3. You can check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 brings me back. Okay, now you want to find your perfect squares in here, which means a pairing. So we have a pair of 2's, right? That's all we have. We don't have any other pairs, so this is it. Now, 2 times 2, that's 4, right? What's the square root? What's the square root of this 4? Well, it's 2. But then we're left with the scraps that weren't a perfect square. 2 times 3 is 6, so I'm going to write this as 2 root 6. So the square root of 24 can be simplified to 2 root 6. Let's take a look. So if I type in 2 root 6, ta-da, same. Okay? Let's go to the next one. It gets pretty easy after a while. Number 3, square root 80. Okay, bigger number. We have some options. By the way, square root of 80, not perfect, because if I hit square root 80, I get a decimal, but I can still simplify. So square root 80, well, I could do 10 and 8, 20 and 4, 16 and 5. Actually, let me show you something. What if I use 16 and 5? Now, that's interesting because I can show you 16 times 5 is 80, okay? If I would just stop right there and write this like this, 16 times 5, I could kind of shortcut this. Even though I didn't get down to the primes, what's the square root of 16? 4, and then the scraps stay underneath. Now keep that answer in mind. Now when I come over here, let me rewrite the problem, square root of 80. So say I would have done 16 and 5, and I just would have kept going. Well, the 5's done. That's prime. The 16 would have went to 4 times 4, or 8 times 2, whatever. These both go further. 2 times 2. This one, 2 times 2. Prime, 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 prime. So my 80 could have been written as the square root of 2 times 2 times 2 times 2 times 5. You can check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 5 brings you back to 80. Now we want to find our perfect squares, meaning our pairs. So 2 times itself is a perfect square, 4, and another one. So check out what happens. Well, what's the square root of this first pairing? The square root of 4 is 2. Now, what about the square root of the second pairing, right? What's the square root of 4? Well, it's another 2. So let's multiply those together in the front. So we had a pair of 2's and a pair of 2's, meaning a square root of 4 and a square root of 4, 2 2's, and then the scraps, 5. What's 2 times 2? 4. Bring the scraps, 4 root 5. So you're going to get it either way. So that should work. 4 root 5, 4 root 5 is the same decimal that we had up above, which is now not showing, but it is the same. Okay? All right, I think I have 2 more. And these 2 I just added on because when I did my IXL, some of the problems had some numbers out in front of the root. So just wanted to show you how that works. So the 7, let's just leave that alone and let's just work on the 90. So what can we break 90 down to? Well, we can definitely do 9 and 10, right? 9 times 10. And then the 9 can become 3 and 3. And the 10 can become 2 and 5. And those are all prime. 3, 3, 2, 5. So the square root of 90 as the product of its primes would be 3 times 3 times 2 times 5. Now let's not forget, bring the 7 down, 7 in the front. Okay, we have a pair of 3's. You're always looking for your pairs. 3 times 3, that's 9. What's the square root of 9? Well, the square root of 9 is 3, so 3 comes out to the front next to the 7. Scraps stay inside. 2 times 5, 10. Final answer, these multiply to 21 root 10. This is the simplified version of the original. And you can see that they're equal, because if I type in 7 root 90, whoa, wait a minute, 7 root 90 is 66.408. And then if I type in 21 root 10, I get the exact same thing. Okay, so then I just had one more. 3 times the square root of 117. 117. I may need my calculator to figure out what goes into 117. Well, I know it's not divisible by 2 because it's odd. So that's not going to work. 58.5 times 2. I don't want decimals. Let me take 117 divided by 3. Let's see if 3 goes into it. Oh, good. 39. So 39 times 3. So let's start there. 39 times 3. Now 3's prime. Now what about 39? Can you think of two factors of 39? Maybe 13 times 3. And these are both prime. So we can write the square root of 117 as 13 times 3 times 3. Bring down the 3 in the front. Here's our pair. That's 9. The square root of 9 is 3. Bring it out. Oh, but there's already a 3 there. Okay, let's multiply them. And now leave the scraps. Final answer, 9 root 13. Let's see if they're the same. So if I type in the original, 3 root 117, I get this. And if I type in the answer, 9 root 13, I get this. So this, guys, this would be the equivalent of like you typing, you know, in your math past, it would be like you reducing, 4/8 to a half. Like they're both 0.5, right? They just look different. That's the same thing we're doing here. They're both equal to the same decimal. It's just one is the reduced version and one of them is unreduced. Now, I have an IXL where you're going to practice this. And just to give you a heads up, your IXL will be just like this. But then my next video is going to say, what's the use of this? So I did a video on what's the use of factoring. My next video is going to be what's the use of this? And I'll show you how it's going to help you in Algebra 2. So there's a reason I'm making you do this. Algebra 1 sets the skill. And then as you move on and you're studying quadratic functions, you start to realize why you need this. So we'll get into that in the next video. Thanks for watching.